All right, so last time we talked about tangents. Today we're going to talk about chords, which are a little harder, I think. So a chord is a line that connects 2 points on a circle. So for example, A to B would be connecting 2 points on a circle, or B to X. Okay, so the diameter, you guys probably are familiar with, is the line that bisects a circle in two equal halves. So it splits the circle into two equal halves. That's AB. And it's a special type of chord. It goes through the center of the circle, in this case M. You'll notice M to X isn't a chord because M isn't a point on the edge of the circle. It's actually the center point. So M to X is actually the radius here. B to X is hitting 2 points, so it's still a chord. And I just want to talk about the term bisector for you guys. A bisector is a line that splits another line into two equal parts, or splits something else into two equal parts. So a perpendicular bisector is one that results in a 90-degree angle between whatever it's splitting and itself. In this example, we have the radius coming out here, and it's perpendicularly bisecting this chord. So it's splitting this side and this side into even parts. And this one is a perpendicular bisector because it has a 90-degree angle there. So there's three properties we're going to talk about for chords that are important to kind of remember and important to work with. Chord property number one is that the line drawn from the center of a circle to bisecting a chord divides the chord into two equal parts. So you could have a line just sitting over here bisecting a chord, but if it's ever coming out of the center of the circle, it's always going to split that chord into two equal parts, no matter where the chord is. Okay, and that's kind of important. It's a little non-intuitive when things are at angles because it tricks your eyes a little bit. But remember, if it's coming from the center and it's uh, a perpendicular bisector to a chord, it's going to split it into two equal parts. And alternatively, you can flip that on its head. If you're not told that this is the center, and if a bisector is perpendicular to a chord, it will pass through the center of that circle. So if you're just given this line and you're given a line and it's 90 degrees, you know that that line will hit the center of the circle at some point. And chord property number three is a line that joins the center point of a circle and the midpoint of a chord is always perpendicular to the chord. So these two, number one and number three, kind of go together. If you have a 90-degree angle there, then you know you're going to have two equal parts left and right. So let's do some examples. This is a little confusing, but those three rules, if you kind of go back to them while you're doing your questions, should kind of encapsulate everything that you need to know. So we'll do a couple examples. It'll teach you the type of question you might see, which I think is always very useful. So these are just the examples out of the textbook, you guys. If you want, you can pause here and try them out yourself first. But we'll start with example number one. Just make sure we're on the right layer here. Okay. So example number one says point O is the center of the circle. So we'll label our center point O, and line segment OC bisects chord AB, and OC is this guy, and AB is our chord. And the angle of OAC, is right here, is 33 degrees. 33 degrees. Sorry, that's kind of hard to read. Maybe I'll bump that up a little bit. There, much better. Determine the values of x and y, and in this case, x and y are angles. So x and y. A couple other important notes that we have here is this is a has one little notch mark, and this has one little notch mark. So we know that OC is bisecting and splitting it evenly. So since OC bisects the chord and it goes through the center of the circle, you can basically draw this in here. We know that that's 90 degrees. And since O to A and O to B are both the radius of the circle, we know that these are actually equal as well. In which case, we can identify that X is the same as this angle here. Because this triangle is the same on these two sides, and since these are the same, then you've basically got an isosceles triangle, which means you've got two angles that are identical. So we know that, oh, I see. Sorry guys, I got an error here in my GIMP file. So we know that 33 plus 33 plus our y, but we can actually kind of go like 2 times y here, would give us 180. That's a little confusing, I think. So I would prefer to just split this into a single triangle here. And we could say 33 plus this 90-degree angle that we have plus y equals 180. And if we do our algebra here, right, minus 33 minus 90 from both sides, we'll end up getting y equals 57 degrees. So we have x, oh, I never actually wrote this down, x equals 33 degrees, and y equals 57 degrees. That's a little messy, excuse me. And that's example 1. You'll notice that a single example now is starting to use a lot of different skills that we've learned. So I always find that circle geometry is where students have trouble and where I had trouble, because you have to remember so much stuff from other units. So have patience with this, and a lot of the time what will happen is if you're not sure how to work through one of these questions, you just need somebody to say, oh, look at it and think about Pythagorean theorem, or look at it and think about like isosceles triangles and how those work. And oftentimes it'll feel like a bit of a light bulb turns on, and you'll recognize, oh, okay, I know how to do this now. Okay, so let's try example number 2 here. First, we're going to label our drawing up here. Oh, is my example 2 mirrored? Oops. Here, let's flip this. That looks better. So we've got A over here, we've got B here, our center is O. This is a 90-degree angle, 10 centimeters. You know, I'm just going to leave the units out because it's hard to write that small for me. Point E is this this middle point of this chord here, and we have C and D. Oh, and A to B is, what is it, 26 centimeters long. So AB equals 26 centimeters. Okay, beautiful. So point O is the center of the circle. AB is a diameter with length 26 centimeters. As soon as you see them saying AB is the diameter with 26 centimeters, you should immediately think, I don't know if it's going to come in handy in this question, but you should immediately think radius is 13 centimeters. It's always half the diameter. CD is a chord that is 10 centimeters from the center of the circle. So our chord here, CD, is 10 centimeters away. What is the length of chord CD? Give the answer to the nearest tenth. So this question, at first, it seems like there's not something you can use to solve it. And the radius does actually come in handy. Because what we can do is create a triangle here using the radius going from O to D. And now what we have is just a Pythagorean theorem question. We have one side, two sides, and it's a right angle triangle. So we can figure out that third side. So what we have, we'll say a squared plus 10 squared equals 13 squared. A squared plus 100 equals, what's 13 squared? 169. A squared, 69. You square root both of those, no problem. And you end up getting A equaling 8.307. But the answer says to the nearest tenth, so we say, oh no, sorry, we're asked for the entire chord, excuse me. So we're given this, right, 8.307, and we're asked for entire C to D. We've got an E to D, so we have to multiply that by 2. So you go 8.307 times 2, and you end up getting 16.614. Round to the nearest tenth, we get 16.6 centimeters. So you'd say CD equals 16.6 centimeters. Excuse me. So that's the other thing that, make sure you don't make the same mistake I almost did, which is go back and read the question. Make sure you're answering what you're supposed to be answering properly. What the heck? Oh, I see. Sorry, guys. Okay, and example 3. So example 3 says a horizontal pipe has a circular cross section with center O. Its radius is 20 centimeters. Water fills less than 1/2 of the pipe. Oh, so this is like, we're talking like we're looking down the pipe. Okay. So water fills less than 1/2 of the pipe. The surface of the water, AB, is 24 centimeters wide. So this is A, this is B. Determine the maximum depth of the water, which is the depth CD. So we have C, where our chord is being connected, and we have D down here. Okay, and the depth then is CD, and we know that our radius would be O to D, right? So our radius is OD, which is also 20 centimeters. So if we take the difference between our radius and we get rid of OC, then we'll be left with CD. So we can write that out, CD equals OD minus OC. And we know OD is 20. And since OC is perpendicular to AB, then AC is half of AB. So since OC is perpendicular to AB, then you know that these things are equal. And what did they say for AB? They said 24. So AB equals 24. And we're looking at AC equaling 12. So if we take Pythagorean theorem, right, if we say this is 12, we take Pythagorean theorem and we have 12 squared plus b squared equals 20 squared. We get 144 plus b squared equals 400. We do some math. You guys can figure that out if you want. You end up getting, oh, not x, sorry. B equals 16. So we know that this line here is 16. And since the entire thing is 20 centimeters, we just subtract 16 centimeters from it. And we're left with this line here. So 4 centimeters is our depth of water there. So this one again uses Pythagorean theorem, but it's a bit more of a complex word problem attached to it, where you have to identify that O to C and C to D when combined is going to give you your radius. And that's kind of the trick with all these questions. You guys might have trouble with some of them. If you do, don't worry about it too much. I would highly suggest asking other people just like the first step, or asking me what the first step to that question is, because oftentimes that's the hardest thing to do with chord questions. Because like I said before, they start bringing in so many different skills and almost like some of them are almost like logic problems. So go through them at your pace. If you don't figure one out very well or can't figure one out, skip it. Write down which ones you're not sure of, and then ask somebody, me or a classmate, kind of where to start. And oftentimes that's all it takes. All right, everybody. Sorry for the long video. Hope the examples helped. Cheers.